Okay, stoichiometry can be a mess sometimes, especially if you don't know where to start. Best way is to remember to do dimensional analysis. You want to read the problem that you're given. How many moles of NO2 are made with 1.5 moles of O2 and sufficient N2? So, first of all, we have to create a balanced chemical equation. So we're going to start off with N2, that's there, plus O2 yields NO2. This is a fairly simple balancing chemical equation, but again, you want to start with what you're given and you want to list your elements. So it's going to be N and O, two very simple elements. Basically make our tic-tac-toe grid, and on our reactant side we have 2 nitrogen, and on our product side we have 1. Again, you don't have to list the 1, but a lot of times, especially when you're starting out balancing chemical equations, it helps to list the 1. So on the oxygen on our reactant side we have 2, and on our oxygen on our product side we have 2. How would I get the same number of nitrogens on both sides? Well, you want to put, you remember you can't change the subscripts. You have to use the coefficient. So I want 2 nitrogens. So that's 2 times 1 is 2. But remember, this coefficient applies to the whole chemical formula. So 2 times 2 is 4. So our nitrogens are now balanced, but our oxygens are not. So we want the same number of oxygens on both sides, so you're going to put a 2 in front of the oxygen. 2 times 2 is 4. And we have the same number of nitrogens, same number of oxygens on both sides. The next thing we want to do is then look back at our formula, our problem. What are we given? We're given 1.5 moles of O2. And what are we trying to find out? How many moles of NO2 there are? So we want to keep our chemical formula, but we also want to then set up using dimensional analysis. So you start with what you're given, 1.5 moles of O2. And I know that everybody just leaves it blank. My brain just does not think in those terms. I have to have the 1, or I'm going to move this whole thing down. So I'll be multiplying the numerator times the denominator, and I won't be happy. So with my answer. So that's why I put the 1. If you can do it without the 1, leave it. Not a problem. So we want our conversion factor. We want to know, we want to go from moles to moles. Moles of O2 to moles of NO2. So we want to get rid of our moles of O2. Remember, there's the same thing on the top and the bottom we can cancel. So, and that works for words as well as numbers. So what we want to do is we want to put moles of O2. But we also need to have a number. So we look at O2. This, if we were to read this formula equation right now, we would read 1 mole of nitrogen plus 2 moles of oxygen yields or makes 2 moles of NO2. So given that, we put the 2, because that's, even though the moles aren't written, we're going to include that, or it's assumed that it's there. Unfortunately, with chemistry, there's a lot of assumptions, and for those starting out as chemists in classrooms in both high school and college, it can be really confusing at times, especially if you weren't taught it properly. So we're going to have, we're going to now have, we got rid of the moles of O2, we want to find out how many moles of NO2. So we're going to write NO2, and we're going to write moles, and we're going to have how many? 2. Why? Because it says it right in our chemical equation. So now we have moles of NO2, and the rest is math. 1.5 times 2 is 3 moles of NO2 divided by 2, which would equal 3 divided by 2 is 1.5 moles of NO2. I'm running out of room. So 1.5 moles of NO2. That is going to be your answer for how many moles of NO2 are made with 1.5 moles of O2. And enough, sufficient means enough, nitrogen. So that's basic stoichiometry. We'll be doing some more